Hi students, today I am going to explain to you one of the very interesting topic in thermodynamics for class 11, that is isothermal process. So we have studied the different types of thermodynamic processes in which the thermodynamic variables such as the pressure, volume, temperature, internal energy, entropy, all belonging to the properties of the system are going to change, or keeping the other one as constant, one or two may change. So whenever a system absorbs heat or gives out heat, there will be some changes taking place in the thermodynamic variables. So this only we call it as a thermodynamic process. So today's topic is isothermal process. So what is an isothermal process means? It is a thermodynamic process in which the pressure and volume will change. So pressure and volume will change. So pressure P and volume V of a system, of any system, will change by keeping the temperature as constant. Okay, so it will change keeping the temperature as constant. So this is very important, keeping the temperature as constant. So this is the definition for an isothermal process. So what is an isothermal process means? You should write that it is a thermodynamic process in which the pressure and volume of a system will change, keeping the temperature T as a constant. Example I will take, for example, now melting of ice, okay, melting of ice at 0 degree Celsius. Okay, second example is vaporization of water at its boiling point, vaporization of water at its boiling point, that is at 100 degree Celsius. So these are all some of the very best examples we can give for the isothermal process. Okay children, now in every thermodynamic process there will be relationship between the thermodynamic variables, particularly the relationship between the pressure, volume and temperature. Understand that? So this relationship among the various thermodynamic variables is called as what? Equation of state. See, pressure, volume and temperature, these are the variables which are called by the name state variables, and hence the relationship between P, V and T is also called equation of state. Now I am going to write the equation of state. So what is the equation of state for a thermodynamic process, which is taken to be isothermal? The equation of state for this isothermal process is P V is equal to constant, because PV is equal to R into T, is it not? See, this is nothing but R into T only for 1 mole. So R is universal gas constant. For isothermal process, temperature also is constant. Therefore, PV is equal to constant. So P initial into V initial must be equal to P final into V final. Okay, so this is nothing but Boyle's law. So the gas obeys which law? It obeys Boyle's law. So PV is equal to constant is Boyle's law. And the equation of state for the isothermal process is P into V is equal to a constant. Okay, now I will write an expression for the specific heat capacity. The specific heat capacity of the system. I can get an expression for an isothermal process. Now specific heat capacity, I will take a small s. Small s is equal to delta Q divided by mass of the substance into delta T. This is the expression for the specific heat capacity, where M is the mass of the substance. Now what is delta T here? Delta T is the change in temperature. Is the temperature changing during an isothermal process? No, because the temperature remains constant throughout the thermodynamic process. Hence, in this process, delta T must be equal to 0. Okay, so here delta T is equal to 0. Change in temperature is 0 because temperature remains constant. So the specific heat capacity is therefore equal to delta Q divided by M into 0, that is 0. And hence delta Q divided by 0 is equal to infinity. So the gas is having infinite specific heat capacity during an isothermal process. Have you understood this concept, all of you? Okay. Now there are two conditions that has to be satisfied. Two conditions must be satisfied for an isothermal process. So what are the two conditions I am going to write here? So what are the two conditions? The first condition itself is the system, okay, or the gas must be taken. The gas must be taken in a conducting vessel, okay, taken in a conducting environment, that is conducting cylinder. That means the entire conductor, the entire vessel should be made up of a conductor, the walls as well as the bottom as well as the piston, everything should be a thermal conductor. And the second condition for an isothermal process is a process, okay, must be infinitely slow. Okay, process must be infinitely slow process. It is not a fast or rapid or sudden process. So what are the two conditions required for the isothermal process? The system should undergo pressure volume changes and the system should be contained in a vessel which is made up of perfect, okay, thermal conductor. Understand? Okay. Second one is what? The process must be infinitely slow process. Infinitely slow process. Okay, now we are coming to the next point, that is the indicator diagram. The indicator diagram. So this indicator diagram is the relationship between the pressure and the volume changes. Okay, so I am going to draw the indicator diagram for an isothermal process. So usually we take the pressure along the y-axis and the volume of the gas along the x-axis. So like this I will take. So this is the indicator diagram. So pressure is taken along the y-axis, volume is taken along the x-axis. Now I am going to draw the PV relationship for an isothermal process at different temperatures. So what are the three different temperatures? Let us say one is less temperature, the other one is moderate, and the third one is high temperature. So first I will take the nature of the graph. Okay, it will be a curve like this. This is at a lesser temperature. And the next one at a moderate temperature, the graph will be shifted slightly higher. And then at a very high temperatures, the graph will be shifted like this. So these are different temperatures. So I will take, for example, T1 is equal to 290 Kelvin and temperature T2 is equal to 300 Kelvin and T3, the high temperature is 310 Kelvin. As the temperature increases, the graph is shifted higher and higher, but the shape of the graph remains the same. Understand? It is not so steep, almost flat, but not a straight line. Understand? So this is the pressure volume relationship and this type of curve for an isothermal process is called by the name isotherm. It is called as isotherm. So how many isotherms I have drawn here? 3. So this is the first isotherm drawn at a temperature 290 Kelvin. This is the second isotherm at 300 K, and this is the third isotherm drawn at 310 Kelvin. So isotherm is the pressure volume diagram or the indicator diagram drawn for the pressure volume relations of a gas undergoing an isothermal process. Such a graph itself is called as isotherm. Okay students, what is the shape? What is the shape of this curve? No, it is the shape is rectangular hyperbola. The shape of this graph is a rectangular hyperbola. Now you take 2 points on this graph. So I will take one point here and the other point here. I will find the slope. Can you see here? There is a y-intercept and there is an x-intercept. So for these 2 points on the given isotherm, I find the slope. And this slope of this graph is equal to change along the y-axis divided by change along the x-axis. So what change is undergoing along the y-axis is changes in pressure, and the change taking place along the x-axis is changes in volume. So dP by dV. So this is found to be equal to minus of P by V. This information is very much required for NEET and IIT entrance examination type of questions. It's a slightly higher level. So the slope of this graph is equal to dP by dV, and it can be shown equal to what? Minus of P by V. So how we got this equation minus of P by V? From the equation of state P into V is equal to constant. Okay, PV is equal to constant. Now pressure of the gas is changing. It is a variable. Volume of the gas is also changing. It is also a variable. Only temperature remains constant, is it not? There are two variables on the left hand side. The right hand side is a constant. Now I am going to differentiate this equation. So that at a time both variables are there. Both the variables cannot be changing at the same time. So I keep P as constant and I differentiate the volume. It is P into dV. Plus volume is kept constant and differentiating P, okay, that is dP, and the right hand side differentiation of a constant is equal to what? 0, is it not? 0. So P dV plus V dP is equal to 0, or V dP, V into dP is equal to minus of P into dV. Okay. Now this dV is shifted to the left hand side denominator. So I can rewrite this dP divided by this dV is equal to minus P divided by this V can be shifted to the right hand side denominator, is it not? So minus P by V. So this only is the slope of the PV diagram, slope of this isotherm. Lastly, I am going to write the expression for an isothermal process combined with the first law of thermodynamics. So the first law of thermodynamics. From the first law of thermodynamics, we have studied that the quantity of heat supplied, to a system is equal to the sum of the internal energy and the work done by the system. Is it not? Okay. What is du here? Du means what? Change in the internal energy. Change in the internal energy depends on the change in the temperature of the system. You tell me, is the temperature of the system changing in an isothermal process? Not at all. So du must be equal to 0 here. Du must be equal to 0. So here du is equal to 0. Therefore the first law of thermodynamics is equal to what? Q is equal to W. So totally the quantity of heat supplied to the system is converted into work done. Understand? So this work is done by the system. That is when the gas expands, when the volume increases, okay, when the volume increases, work is done by the system, then W will be positive. Suppose if you compress the piston downwards, the volume decreases. Understand? The volume decreases and work is said to be done on the system. So in that case, W will be negative. Understand? That we are going to study separately in the next topic. Okay, my dear students. Now we have studied what an isothermal process is. So isothermal process is a thermodynamic process in which the compression or expansion of a system will take place at constant temperature, or otherwise we can say that the pressure and the volume of a system changes by keeping the temperature as a constant. So example, we have given a melting of ice at its melting point and vaporization of water at its boiling point. So these are all the other informations we must remember regarding an isothermal process. So next we are going to derive an expression for the work done by the system during an isothermal process. I hope we must have understood thoroughly about the isothermal process. Fine.